Welcome back to this video lecture series on data structure and algorithms. Today we'll be talking about a very important algorithm named Dijkstra's algorithm. So this is also called as single source shortest path algorithm. What it does is that if we want to go from one node to another node, then using this algorithm we can find the shortest path, that is the path that takes minimum cost to reach from a particular node to another node. So let's have a look at the steps we'll be needing to incorporate this algorithm. So first we need to create a cost matrix C from an adjacency matrix that we'll be having. Now this cost matrix Cij will be the cost of going from vertex I to vertex j. If there is no edge between vertices I and j, then C of ij is infinity. So if two nodes have no edge in between, then the distance or the cost will be supposed as infinity. Otherwise we'll be having a certain value for that edge, that is for going from that vertex to another vertex. The second step is that we will be having another array called visited, which will be initialized to 0, and we will be using this array to keep a track on the nodes which are already visited in the path we will be having, the path that will reflect the shortest path to go to a node from a particular node. Now if the vertex 0 is a source vertex, then visited 0 will be marked as a 1. So visited I is equal to 1 means node I is already visited and we cannot manipulate the value within this node. Next, we will also create a matrix distance by sorting the cost of vertices from vertex number 0 to n minus 1, where n is the total number of vertices from the source vertex 0. Now initially the distance of source vertex is taken as 0, that is distance of 0 is equals to 0. For the last step, we'll be having a for loop which will iterate through all the nodes of the graph, and in here we'll choose a vertex w such that distance of w is minimum and visited of w is 0. Then we mark visited of w as 1. We recalculate the shortest distance of remaining vertices from the source. Now only the vertices not marked as 1 in array visited should be considered for recalculation of distance, that is for each vertex v, if visited v is equals to 0, then distance v will be minimum of two things, either of distance v or the distance w plus cost wv. So all these theoretical aspects will be understandable betterly if we take up an example and when we jump onto the coding part. So we take up this example of this graph where we can see 5 nodes are there, 0, 1, 2, 3, 4, and let's choose 0 as the starting node. So as we can see, the adjacent nodes are 1, 3, 4. So at the beginning, all these nodes 1, 2, 3, 4 has the distances marked as infinity. Now, as we can see, these are adjacent, so we can set a value for all the nodes. Like 1 will be having a value of 10, 3 will be 30, 4 will be 100. Now as we can see that from 0 we can go to 2 via 3. So we can say that this node 2 will be having a value 30 plus 20, 50. So infinity is replaced by 50. Now as 0, all the adjacent nodes to 0, 1, 3, 4, the 1 has minimum value. So we mark the node 0 visited and go to 1. Now as we can see, the node that is adjacent to 1, that is 2, it already has a value of 50, and from 0 to 2 via 1 will have a value 10 plus 50, 60. So 60 is greater than 50, so the value will not be replaced here and will jump from 1 to 2, so this will be marked as visited. So one point is that we will not actually mark it visited, because as we can see that the 2 node has a value 50. If we go to 2 via 1, then it will cost me more. So I'll not use the route 1. I'll rather use the route via 3 to 2. So for now the path is 0 to 3 to 2 because it costs 50 here. So as this point of time, 1 has a value of 10, 2 has a value of 50, 3 has a value of 30, and 4 has a value of 100. So we traverse the path 0, 3 and 2. Now when we are at 2, we can see that 1 has a value of 10, and if we want to go to 0 to 1 via 3 and 2, it will have a value greater than 10. So there's no point in changing it. Then as we are going a path from 0 to 3 to 2, that is 3 is a predecessor of 2, so we cannot change the value, that is 0 and 3 are already marked as visible. So from 2 we have only 1 and 4. We have already seen 1 cannot be, the value of 1 cannot be replaced because it is already least. Now if we see at 4, we know that the 4 has a value of 100. Now if we go to 4 from 0 via these two nodes 3 and 2, we can see the distance is 30 plus 20 plus 10, 60, which is less than 100. So we can replace the 100 value with 60. So just like this, using this algorithm, single source shortest path, we get this path 0, 3 to 4, which costs 60 rather than 100 that would take us to go from 0 to 4 directly. So let's now jump onto the coding part and see how we can implement it. Okay, so I have opened my IDE and I have already typed down these lines of codes. These are very simple and basic lines of code that is used to make the adjacency graph of the adjacency matrix of the graph. Sorry. So here in this Dijkstra's algorithm, we'll first, after creating the adjacency matrix, we'll ask from the user for the starting node. So we'll ask the user that enter the starting node, a new line. Now for that, here I'm going to take a variable called start, and in here I'll use simply scanf %b ampersand start. So now we will actually implement this Dijkstra's algorithm function. For that we'll use a function, let's name it Dijk. Sorry. Now the arguments here will be the adjacency matrix itself, the G, the number of the vertices n, and the start node. That's it. So the main aim for this program is to define this function properly. So let's do it here. So the return type will be void, and here I'll have to define these arguments properly. So now as here I have already defined two macros, like max. Here max I have already defined 10. So let me just do one more thing. I'll define another thing. I'll call it infinity, like I'll take on the inf and I'll give it a value as this, so any random big value. So here again, coming back to defining the arguments, so this will be max, again this will be max, this will be int n, and lastly this will be int star. Let's get rid of this semicolon. So here, so first I'll take some arrays that I'll be needing, and one matrix I'll also be needing, and some variables. So the first matrix that I'll be needing is the cost matrix. So cost, again max and max. Then a matrix that I'll be needing is a distance. Another is array that I'll be needing, visited array, and another is predecessor. So I'll just name it pred. Well and good. Okay, the sizes will be, let's say I can give it max only. So max now in here I'll be needing some variables also. So two variables for the loop. Then I'll need a variable count to traverse through the nodes. I'll need a variable minimum distance, so I'll name it minimum distance, and another that I'll be needing is the next node. So next node. So now here I'll first start filling this cost matrix. So I'll take for loop, rather two for loops here. For I is equals to 0, I less than n, I plus plus. Another for loop, j is equals to 0, j less than n, j plus plus. Now in here I'll check first if I can see that g of I and j is equal to 0. That is, there is no edge in between I and j. So what I'll do is the cost for those two nodes will be infinity. So I j, cost of ij will be infinity. Otherwise, if that is not the case, then I'll simply do cost ij is equal to g of I j. Well, now I'll do one thing, is that I'll handle the predecessor and distance arrays. So I'll run a for loop here from 0 to again less than n I plus plus. So here the first thing that I'll do is distance of I will be cost of start node to the I node, then the predecessor matrix, that is spread I will be the start, and lastly the visited will be having a value of 0. Now after this, what we'll do is distance of the start will be assigned with a value of 0, and I'll mark this start node as visit. So visited of start is equal to 1, and I'll initialize the counter value with the node 1 that is next to 0. Now here I'll start traversing through the nodes. So here while count is less than n minus 1. So first I'll try to get the next node. For that I'll simply run a for loop I is equals to 0, I less than n, I plus plus. So here I'll check a condition, is that if distance of I is less than the minimum distance and it's not visited, so not visited I. Okay, one thing here, this minimum distance, well, we have to just define it. Here we will actually define it. Minimum distance will have a initial value of infinity. Okay, so if this is the condition, this is satisfied, then what we'll do is distance of I will be minimum distance will be distance of I and the next node will be I. So after this, what we'll do is we'll make the visited of next node as 1, and we'll check if a better path exists or not. For that I'll again run a loop 0, I is less than n, I plus plus. So here we'll first check if it is not visited, so not visited I. Then if the distance thing, that is if minimum distance plus cost of next node I is less than the current distance it has, then what we'll do, I'll just copy this part because I'll be using it, and I'll keep it within a parenthesis. So wait, yeah. here right there. So if this is the condition satisfied, then I'll say this if I will be this. And now as this condition satisfies, then we have a better path, so we have to keep track of this predecessor node. So pred of I will be next node. Now lastly, will increment the count of the loop. So as we can see at this line here, the while loop is finished. So now it's time to print down like what are the effects of this while loop, or rather this algorithm. So for that, again I'll run a for loop here. I equals to 0, I less than n, I plus plus. I'll first check a condition, that is if I is not is equals to start. If this is the condition, then I'll first print a message that the distance of node percentage d is percentage d, and the first percentage d will be the I, and next up will be the distance of I. Very good. Then I'll again print down this message, printf the path is percentage d. Here it will be I, and for the next part, that is to complete the path, I'll first take I into this j. I'll run a do while loop here, while j not is equals to the start. I'll do j is equal to pred of j, predecessor of j, and I'll print like this, percentage d comma j. This is it, and I'll just print a new line here so that I can get the differences between the paths and the messages printed. So yeah, this is almost the thing that we wanted to do. So let's now save this code and run this code. So here is the output, and I'll be taking reference of this graph only. So the number of vertices will be 5. Now let's enter the graph. So starting from here 0. So first 0, then to 1 10, then there is no link with 2, so 0, then with 3 30, then with 4 100. So like this I'll keep getting this graph view. Now they have asked me to enter the starting node. Let's say I want to start with 0. So here is the output. It says the distance of node 1 is 0, as we can see, is 10, as we can see. Yes, this is 10, and the path is, so 1 is from 0 to 1. Now the distance of node 2 is 50. You can see 30 plus 20, 50, and the path is 0 3 2, 0 3 2. The distance of node 3 is 30. This is the shortest path, so 30. And the distance of node 4, this distance refers to the shortest distance, is 60. As we can see, 30, 20, 10, 60 rather than 0 to 4 directly. So this is how you could actually implement the Dijkstra's algorithm and get the single source shortest path algorithm proper. Thank you for watching this video and staying with us. See you next time.